The purpose of this video is going to be calculating x and y intercepts. Basically, what you need to know is that if I am calculating an intercept, I am going to be plugging in a 0 for a variable. Again, if you see this word intercept, you should know you are plugging a 0 into your equation. Like I say here, i.e., you are then going to essentially be solving for one variable knowing the other is 0. Now, in Algebra 1, what is extremely important to know is we are studying lines, or we begin to study quadratics at the end, but for right now, this video will be focusing on x and y intercepts of a linear function, or a linear equation. So, what that means is that we're dealing with something that is a straight line. Now, why is it that straight lines are important? Well, straight lines are important because once they pass a certain value, they never return to that value ever again. So, if I have an x or a y intercept for a linear function, there can only be one and one only of each type. There are functions later on that you would study that can have multiple x and y intercepts, but we are right now just talking about the basic, which is a line. So a x or y intercept based off of the line I just drew, okay? What you need to know is that this is the point where it crosses the x or y axis. A straight line, again, will never return back to a different x or y intercept. So what we can do is use that to our advantage. And what I mean by that is if I know that it only happens once and only once, one little tool you can use for x and y intercepts is to make an xy table, and an x or y intercept again means you are going to be plugging a 0 in for one variable and solving for the other. So in the table I place a 0 in the x, and then the second time I place a 0 for the y. Now, the next thing we need to note is that which one is which. Is the first one right here, is this the x-intercept or the y-intercept? Or is the second one the x or the y? Well, there's a very easy way to tell. In the first line, you can note that I am going to be solving for the y variable. Because I am solving for the y variable, that will be the y-intercept. So, in other words, the variable I am solving for is the intercept I am calculating. So this is the y-intercept. The bottom one here, this level here, will be calculating for x, so I am using the x-intercept here, okay? That's important. This is a tool that I will be utilizing throughout the rest of this video. So let's go do some examples. So, first example, determine the x and y intercepts for y equals 2/3 x plus 8. Again, my tool, I hear intercepts, I immediately go to table, and I say 0, 0 diagonally because intercepts mean I am plugging a 0 in. So when I plug a 0 in for one variable, therefore I am going to be calculating the other. So the first time here is I have two coordinates. So the coordinates I have here are 0, y. I am looking for the y-intercept in the first row. So what I am going to do is simply use the table. Now the table tells me, okay, what variable I can plug in for. So the first time here it says x is 0. So 0 is in the x column, which means that in this equation, any number in this column I can place for x. So I'm going to go ahead and do that. So the y-intercept, again, I'm calculating because y equals 2/3 times 0 plus 8. And what I get is y equals 8. Now, this is not my final answer. You need to plug that 8 into the table so that you can say the y-intercept is the coordinate pair 0, 8. On to the next one, x-intercept. Again, I go back to my table. I look at this column. This is now the row I want to fill in. So this row has a 0 in the y column and a blank in the x. So what I can do is I can go to my equation again, and this time I can fill in 0 for y, because 0 is in the y column. So this time it becomes 0 equals 2/3 x plus 8. Now, at this point, this one becomes a little more challenging because I actually have to follow through and solve for x. So what I'm going to use are properties of equality. The first property of equality I'm going to use is the subtraction property of equality. So I'm going to do -8 minus 8. I am now left with -8 equals 2/3 x. Now, at this point, I can go either way. I can choose division, or because it's a fraction, I can choose multiplying by a reciprocal. I am more of a fan of choosing multiplication by a reciprocal, so I am going to multiply by 3/2, both sides 3/2. If you want to divide, you go ahead and divide. You can use your calculator to help you with that. Either way, you should know that division of a fraction is the same thing as multiplying by a reciprocal. So the multiplying of the reciprocal on this side turns them both into 1, and I'm now left with just x. On this side, what I can do is I can either, 1, type it into a calculator, or I can do some mental math. The mental math I can do, instead of doing 3 divided by 2, I can switch the 3 out for the -8 and ask myself, what is -8 divided by 2? Since I can do that, great, it is -4. I then take that answer of -4 and multiply it by this 3 that I did not use. So -4 times 3 is -12. So I get x is -12. Again, this is not my final answer. The answer is back in the table, is the x-intercept is -12, 0. So if you got lost in the mental math I was doing there for this problem, don't worry. You can use a calculator if that is confusing to you to help you solve that answer. Let's try another example. The next example. Now, this problem is another type of equation you will see in Algebra 1. This is called standard form. However, because I changed the equation type does not mean I change the way we do an x-intercept. If you hear intercept, you should immediately run to your tool, which I like to use is the table, because I hear word intercept and I go, I'm plugging a 0 in. So I usually start off with 0 in the x, and the second one I will do 0 in the y. So to do this, you follow suit again as normal. Whichever column has the 0, you plug in for the first time, and then the other one the second time. So the first one here, again, I'm going to be solving for y because it's blank, so therefore I'm finding the y-intercept. So by going to my equation, 3 times 0, and why am I placing a 0 next to 3? Well, because x is next to 3, and x is my 0 for the first row. So x is 0, 0. So we move on. Plus 7y equals 28. Notice I now have an equation in which I'm left to solve for the other variable. I am left solving for y, so I am finding the y-intercept. 3 times 0 is 0. I don't need it in the equation, so I'm now left with 7y equals 28. And this step is the divide by 7, divide by 7. I get y equals 4. Again, just saying y is 4 is my intercept is not correct. Plug it into the table so you know that the y-intercept is 0, 4. On to the next one. So this time I go 3x plus 7 times 0 equals 28. Because I am left with an x in the problem, I am finding the x-intercept. So it is 3x equals 28. Divide by 3, divide by 3. I get x equals. Now, there are 3 different ways you could leave this problem. You could leave it as a decimal, you could leave it as a fraction improper, or you could leave it as a mixed number. More often than not, you will see this left as an improper fraction in Algebra 1, so that's how I am going to choose to leave my answer. 28 over 3, there is nothing that I can reduce by, so my final answer is 28 over 3. So in the table, I put 28 over 3, 0. Now, if I have to graph this, I am definitely going to try to probably put this into a decimal, and the decimal in this case would be 9 and 0.3 repeating. So if I have to plot this point, I'm going to put it somewhere close to 9, a little bit beyond it, and I'm going to say 9 and 9.3. What I hope you get out of this is the fact that we're simply talking about placing a 0 in for one variable so you can solve for the other. The variable you are left solving for, again, is the intercept you are actually calculating.